stressful time being so late.
Thank you for this, Matt.
Hey
Thank you.
there, welcome to Astronomy Daily Live. It's 2:01 UTC, and it's time again to gather together and think and talk all things astronomy and space and science and just the whole thing, right? We have the entire universe to think about and talk about, and that is what has kept me extremely interested in all this my entire life, right? Is that there's just so much that it's really amazing. So I'm going to pull up the chat here, make sure that that's all happy and going good. Yeah, so come on in, grab your consumable of choice, and let's sit back and think and talk astronomy. We're gonna do yet another just sort of fun casual get together. There's an interesting event that is going to be actually coming up here in just a few days, and I want to talk about that first. Well, you never know where things are going to go. So we'll see how all this goes. But I would like to welcome for the first time on the panel, Mr. Tim. Hey, what's going on? All the way from the UK.
Thank you for allowing me on, buddy. Thank you.
Oh, absolutely. Wow. You've got a very festive background there. That's pretty nice. All right, here, let's here I can wow, okay. You have definitely decked the halls. Those halls are decked. That's great. That's absolutely great. I'm really boring when it comes to holidays and stuff. I'm just sort of a boring dude. So I just sort of have the regular things. I did rearrange things in here today, so got something done. And also on the panel once again is Bobby. Hey, Bobby, what's up?
Hey, what's up, everybody? I was just actually was watching like a little show that Ron directed me to and stuff.
That's cool, Bobby. You are breaking up. You're breaking up like crazy. I got almost none of what you just said. So push some buttons or something. Get the hammer out. Bang on that thing a little bit. Cook that potato a little bit. Maybe it'll work.
Breaking up.
Yeah.
Again?
Yes. You are completely. I'm not.
2.
I heard 2, and that's it. Technology's gonna bite. Yeah, not happy.
And as I was saying, I was
lost you.
Ron will me again.
Sort of. That technology, I don't know. Someday we'll get it right. Who knows? But I think where I wanted to start was actually with New Horizons. I'm gonna like immediately share my screen here. So I want to show you this awesome picture of that. Is that cool or what? This is the 70-meter radio dish. Yeah, I'm getting a little.
Can you hear me?
I'm getting you a little bit, but not very well, Bobby.
All right.
Not very well.
All right. I'm gonna do something about it.
All right, he's going to get the hammer out. But let us gaze at this 70-meter radio dish. This is
Okay, check it 1 2. Check it 1 2.
That sounds a little better.
Yep. For some whatever reason, my internal mic is not working. I just swapped it out with the with my USB mic, and everything should be all right by now.
Oh, all right, all right. Whatever works, whatever works. So there it is. This is the 70-meter dish in Canberra, and this is the dish that I guess is talking to the New Horizons spacecraft, which is just a few days away from the trans-Neptunian object that they've named Ultima Thule. And in just a few days, in fact, we're going to go to that site next. New Horizons is going to be doing.
I was on one of Ron's friends' live stream for about an hour and stuff. And it's called Flash in Your Pan.
Flash in Your Pan?
Yeah.
Okay.
And it's all about prospecting.
About what?
Prospecting.
Oh, very cool. Very, very cool. Yeah. You know, of course, where I live, there's gold and silver and copper and lots and lots and lots of things here. You know, this is like a prospector's dream where I live. So yeah, you know, there's actually a lot of mining here still. We have a town just to the south of me called Bisbee, and it's got a big, huge pit mine, right? That you look over the edge and you can't see the bottom, right? It's so deep. So pretty amazing. You know, they're still very active there and everything else. Anyway, cool, very, very cool. Anyway, so this is the 70-meter dish, right? So from this edge to this edge is 70 meters, right? It's absolutely huge. You really, you know, I mean, you can sort of get a sense of scale, right? You know, because you can see all the trees down here and stuff. It'd be nice if they put a little person or something. I guess down here, when this thing isn't in the way, is a little door. Right, so yeah, that's just a massive dish. And in fact, what we can do before we go to the New Horizon is we can actually go to another site that's called BSN Now, and it'll actually show you so right now, right, the 70-meter dish is talking to New Horizons right this very moment, which is very, very cool. Let's look at the signal strength. I always like to do that. Let's see. So it's at 1.39 times 10 to the 21st kilowatts. So negative 148.56 dBm.
Also at the daylight, it's not like they're receiving that very much and stuff. About 1 kilobit. Yeah.
No, they that's sort of intentional. They wanted to pack the spacecraft full of detectors and, you know, all kinds of instrumentation, and so they kind of minimized the radio signal, just to barely be able to hear it. But yeah, they're getting data right now. So that's very, very cool. So that dish there is talking to New Horizons as we speak. So this is a pretty cool site here. Let me copy that. I'll put that in the chat just for fun. Hey there, Ron. Nice to see you. Who else we got? Okay, that's it so far. Good.
Hello, ART Radio, by the way. Long time no see.
Cool. And Tim, you know, we are really loose here, so feel free to chime in whenever you want. I'll stop talking. So you know, don't feel as though you're being rude or anything, because you're not.
I'd prefer not to interrupt. I keep switching my microphone power off so that I can't.
Okay. Well, you know, like I said, you know, this is sort of like a porch, right? You know, we're sitting around the porch and we're just chatting, right? So, you know, when that happens, you know, there's interruptions and, you know, conversation goes wherever it goes. So
as long as I can have the chair where the glass of whiskey is.
There you go. There you go. Excellent. Yeah. I want this to be really loose, casual, and fun, right? So I mean, it's not me necessarily, you know, standing up on a soapbox and you know, pronouncing things. It's a conversation. So yeah, feel free, you know, to dive in whenever you want. That's sort of the whole point here. So, all right, well, New Horizons is going to be passing by this asteroid on January 1st at 5:33 UTC. So, you know, for those of us over here in North America, that's, you're going to be late evening, actually, on the 31st. So I don't
think as long as we're still here, if we're still have to see the ball drop, we should be okay, huh?
I think so. I'd much rather see a brand new asteroid than see a ball drop. So you know, the from what I've heard, the NASA website might be down because, you know, we're going through some kind of a government shutdown of sorts. So, you know, they're having to turn off a whole bunch of things because there's no money to pay anybody. But JPL is going to be hosting, you know, sort of the event, and so, you know, we're not going to miss anything at all. Now, we're not going to actually get any like images back for a little while. We might be able to find out what the timeline is here. Now, you know, as this normally goes, I don't have anything planned, so we are going together through this. And what I'd like to see is sort of a timeline. Let's see if there's anything obvious here. News archives, science shorts. I'm not seeing any timeline. I would really like to see a timeline as to when to expect sort of the first images, the first data. It's going to be a few hours, I think. I think that's sort of the plan. Yeah, it's going to be a little while. It's going to be a little while. Not too long, though. But, you know, I mean, it takes, I think the light travel time is something like, I want to say, wow, I don't even know if, does it say here? No. Wow. Okay, where is New Horizons? Let's see if that helps us. Let's see. Solar system distance calculator. Okay, so round trip light time right now is 12 hours and 15 minutes. right? You know, that's for light, like radio light, to go from Earth to the asteroid. And then of course it has to go back too. So pretty amazing, pretty amazing. There's the path that it has taken so far. I'd really like to yeah. I don't see any timelines here in terms of data when we're expecting to see the first bit of data. But there it is at the moment, at least. So very, very cool. Just a couple of days left, right? What did it say? 6 days, 4 hours, 15 minutes. Yeah, less than a week. Less than a week. And one of the interesting...
I'd like to welcome Uncle Bill Duran. Every port of space probe is a trade-off in mass. High wattage, high bandwidth transmitters are heavy.
Absolutely. Absolutely. Yeah, yeah. So, you know, I mean, New Horizons is doing great. That's actually a pretty good signal. You know, that's a pretty strong signal, relatively speaking, right? I think the Voyager are down around like negative 158. So you know, that's actually, I think, a pretty decent signal. So let's see, the 70 meter at Goldstone looks like it's receiving data from the Mars Reconnaissance orbiter, and wow, that's like serious power, right? that's
4 megabits and stuff.
Yeah,
and
yeah.
It's a bit weird that the DSN doesn't even use the internet. They just use just use what's in space.
Yeah, it's just radio. It's just radio. You know, the Deep Space Network is, you know, sort of the first, one of the first networks, you know, to deal with things like Mars, Jupiter, Pluto, you know, all that. The infrastructure, you know, needs to be built, and we are doing that slowly. But you know, this is what we've got at the moment, and I think it's great. So yeah, it sort of looks like, I think when it's doing this, right, I think they are sending and receiving at the same time. I think that's what it means. I think if it's doing this, it's just receiving, I think. Don't quote me. But yeah, cool. So it looks like one of the 34 meter telescopes. I think, is this, I don't know. Actually, I don't know what size that is. I think they're 35s, 34, 35, and then each place has a 70 as well. But let's see, they were just talking to the OSIRIS-REx spacecraft, which is actually at the asteroid Bennu right now. They're actually going to be sort of putting it into orbit. It's not really an orbit. It's just co-orbital with the asteroid. And it looks like they are receiving data down as well.
Nice one, Uncle Bill, yeah.
Tim's laughing at something. What is that?
Uncle Bill's message.
Oh, Uncle Bill. How'd they do that? That's
cool stuff, mate.
that's horrible. That's horrible.
So,
yeah.
How is
What's that, Bobby?
I was asking Tim how's Sue.
Much better than she was, but still in a lot of pain. Still got her on CBD and morphine and things, but
cool. How's the CBD working?
Pretty good, actually. Pretty good, yeah.
Yeah, that that really helps for all kinds of inflammation and that's a cause of a lot of pain right there. So if you can control that, yeah, pretty nice, pretty nice. Well, hopefully she's going to heal up. Yeah, hopefully.
Definitely, but thank you all for asking.
Good,
That
good,
means
good.
a lot. Means a
Very
lot to me. Does that? Thank you.
Yeah, Ron, there actually is a place that you can go right now. It's called Radio Jove. Radio Jove. And there it is. They actually can supply you with a little kit, to build your own radio telescope and collect data from Jupiter. Yeah, absolutely. And people are doing this all the time. Somewhere here, they've got a link to the data. Is this it? Let's see. That just got us back to there. Ah, here it is, data archive. So, these websites are, from the 1990s. So it's a little crude, but looks like they really haven't, nobody's really been looking at Jupiter. Oh, there go the doggies. Yay. But it looks like they've been looking at the galactic background. Let's look at Jupiter, though, here really quick. And
I've got headphones on full belt here. I nearly shit myself then.
Well, we know who's in charge at this house.
Yeah, and here it wants to know if you can post that link in the chat.
I can. So here's I don't know how to interpret this data, but there's some actual real data from Jupiter. Like I said, I'm not exactly sure what any of this means or represents. Let's see if there's. Oh, okay, that just saved it. So yeah, I'm not quite sure how to interpret this, but yeah, it's all there. Let's go back and we can go here. Here you go, Ron. Check this out. Go like that. There you go. Yeah, and I think they have kits. Yeah, kit ordering. So yeah, it's all here. Oh, I guess you have to pay for it. Yeah, of course. I guess they have all the pieces. Yeah, they've got all the pieces. So pretty cool. Pretty cool. Yeah, no worries. No worries. So yeah, it looks like they're still talking to New Horizons here. Let's see.
Looks like I think we're receiving data.
Yeah, well, it looks like they're sending, right, and receiving. And look at that, they're pushing out almost 18 kilowatts.
18 kilowatts.
18
Wow.
kilowatts. Yeah.
Holy
and that's
18 kilowatts to reach that spacecraft that's going to that little exoplanet or something?
Yes, sir. Yes, sir. Don't get in the way of that beam. You'll get cooked.
Matt, 18 kilowatts. What sort of distance are we talking?
We're talking very, very far. Let's see. Where
I know, like my radio station that's about a couple of streets down. If you go like westbound, pushes 16 kilowatts, and I can still hear it from 2 streets down to right here.
Yeah. Oh, yeah. Of course. So we're at. Let's see. Let's see if we can figure out exactly how far away
Roughly,
we
we'll do.
are. Oh, okay.
It's some distance. Wow.
So 44.19 astronomical units, and an
What?
yeah. So an astronomical unit's about 140 million kilometers. So
Wow.
140 million times 44.19 is about 6.2 billion kilometers away. 6.2 billion.
I wouldn't
So
rely on Wi-Fi for that.
it's pretty far. It's pretty far. So yeah, they have to push a lot of power out there, right? Because otherwise, the spacecraft is not going to hear it, right? And the spacecraft has to,
I'd love to know what the time delay is on that.
It's the light travel time, they say here, is the round trip time is 12 hours and 15 minutes. So it takes a little bit over 6 hours to send a signal out. And so, yeah, what they do, to make this all go, right, is they send up all the commands, days or weeks in advance. And then it just runs through all the instructions, so they have to plan all this out way in advance. And then, yeah, it just does its thing, right?
It makes sense. They've got to factor in time delay and everything else.
Yep, absolutely. And yeah, I think I can't be sure about this, but I think, the time that they are talking about here in terms of when the flyby occurs, I think that does take into account the time delay. So the actual encounter, I think, happens 6 hours before this. We just sort of know about it 6 hours later, right? Because we have to wait for that kind of information, to travel, from there to here.
That kind of distance, though, 6 hours is pretty impressive.
That's pretty far. It's definitely not the furthest, though. Voyager 1 and Voyager 2 are way out there. I think they're somewhere like 120, 3 times the distance. So yeah, they are way out there, and I think
they're now outside our solar system, correct? Yeah.
That's sort of the what they're saying is that they've sort of moved past that edge and are now out in just regular space. So yeah. So yeah, this is going to be a pretty exciting event. The interesting thing that I just heard a couple of days ago is that they've been looking at the light curve from this asteroid, and they are a little bit surprised by how it's not changing. They were sort of expecting, I guess, variations to be a little bit more, because they thought that that this asteroid had a particular shape. It was like either some kind of binary asteroid or a lobed asteroid, and so as it rotates, the brightness is going to change. And I guess they're not seeing that now, so they're not exactly sure why. So we're just going to have to go there and find out. It's going to be a surprise, and I think it's going to be absolutely fantastic, no matter what, right? It's going to be very, very cool. This is the furthest object out that we've ever seen this close, and they are going to get incredibly close. I think closest approach is something like, oh wow, I want to say like 2,000 kilometers or something like that. Let's see if we can. Man, I wish that this site had a little bit more info. Current position, passing the planet, journey through the Kuiper Belt. Mission timeline. Let's see if the mission timeline has any info on when to expect.
Where's Mr. Tom tonight?
Oh, I don't know. He's looks like he's otherwise occupied.
No problem.
Yeah, no worries. No worries. So there's the Pluto encounter. So, yeah, okay. Jupiter.
And who launched New Horizons?
Who? Well, here's the launch thing. It was on top of an Atlas V. So a big push. Big push. Launched back in 2006, right? So they've been doing this for 13 years now.
2006?
Yep, 2006. Wow. Yeah, it took them a long time to get out there. Long time.
I must admit, I thought it was after 2006.
Yeah.
Maybe 2010.
Yeah. No, they've been going for a long time. I forget the exact path. They went by Jupiter and got a little boost. I think that's it. I think Jupiter was the only one. Do we have a yeah.
Do you mean the
okay.
slingshot effect?
Say that again, Tim?
Do you mean the slingshot effect?
The slingshot effect. Exactly.
Yeah.
Exactly. This is a little bit hard to see here. Let me zoom in here on this. Whoop, that's probably too much. Whoop. Let's see if we can get this picture here to where'd it go?
Pardon me for saying something, for interrupting, but I think this is just brilliant that we can talk live. It's awesome.
Oh, I think that this is great, and this is, I think that we ain't seen nothing yet.
I think we've got a lot to come.
I think so too. But yeah, I think this is absolutely fabulous. So there it is. Okay, so they launched January of 2006. Jupiter encounter about a year later, and then a straight shot to Pluto, which was back in 2015. So and
8 years.
Yeah.
8 years on that trajectory. Wow.
Yeah. They actually put it to sleep for most of that, right? They basically turned everything off and just let it coast, right? And then I think I don't know how many months before the Pluto encounter, they turned it back on. Make sure everything worked. It did. I think about a week before the Pluto flyby, the spacecraft actually went into safe mode. There was some kind of weird problem with the memory or something. I forget exactly what it was. And, that was like major panic, right? But they got everything fixed, had the Pluto flyby, and then it's like, well, what else can we do? And they looked out and they found that they could actually fly by Ultima Thule, which is exactly what they're going to do.
I always find it amazing. The original moon landings, they did it on little more than the power of a calculator. awesome.
Oh yeah, yeah. It's amazing, you know, what can be done. You know, we humans, right? I mean, we're capable of such amazing things. Um, you know, there just sort of has to be a will to do it. And, you know, I think the sky's the limit, right? I mean, we can do anything we want. We just have
Dead
to,
right.
you know, quit fighting about all these dumb things, you know? Uh, yeah.
Yeah.
So
Yeah.
this is a pretty cool.
Before you continue, Cosmic, I
Uh-huh.
was actually watching some videos about how did the New Horizon capture Pluto and its moon,
Mm-hmm.
and I think it was pretty darn cool.
Very, very awesome. Very, very awesome. Yeah. Say
Where's
that
my
again,
bloody
Bobby.
whiskey?
Merry Christmas, 9-inch colors.
Hey, 9-inch Colas. Nice to see you in the chat. Welcome, welcome. We're talking about the New Horizons encounter with the asteroid that they've called Ultima Thule. That's not an official name, but yeah, you know, whatever they want to call it, it's fine with me. It actually does have an official designation, which, let's see, can we, yeah, let's go back here and see what its designation actually is. So it's called 2014 MU69. So 2014 was when it was discovered. MU69, I think, has to do with the location and, you know, maybe a closer date. I forget exactly what that is, but yeah, you know, they want to call it something else. It's fine with me. I don't care. Just go look. Now, after this encounter, right, there may be further opportunities to actually go by other Kuiper Belt objects. So, you know, they're going to, yeah, you know, so they're going to do this, right, and then they're going to, you know, figure out what to do next, because New Horizons is nuclear powered, right? So, I mean, it can, you know, I mean, well, what it's been going for 12 or 13 years now, it's got at least another 20, if not more, right? So you know, who knows? You know, who knows where it's going to go next? They're finding, you know, new objects out there all the time. I think there's something like 3,000 trans-Neptunian objects known, and there's probably at least millions, right? Probably at least millions of them. So, you know, but we have to find them first, because we have to know, of course, where to point this thing. So, but very, very cool. So yeah, definitely take a look at this. A few more days, and like I said, I think the first pictures are supposed to come down. In fact, here's some tweets. Let's just see if they give any kind of timeline here. I think this did. This actually was a really, really, really great article that came out just a couple of days ago. They've got some pictures of it, right? Which is very cool.
Is that P46?
This is it, right there. No. This is the asteroid. This is the asteroid that New Horizons is going to be passing by.
All right.
In a couple days. Yeah.
My apologies.
Ultima Thule. So let's see. Yeah, so they're going to be going within 3,500 kilometers of it. So that's insanely close.
Wow.
They're going to get some nice pictures. They're going to get some nice shots. Let's see, encounter mode. Yeah, so they're going to be starting the encounter mode, I guess, today, right? December 26th, UT time at least. Let's see. I'm just seeing if they give any kind of timeline here. What will Ultima reveal? No one knows. Those are my 3 favorite words.
No
I
one
like
knows.
it. No one knows. I like it. That's exactly how it's supposed to be. Okay, here. So close approach, pictures, spectra, and all that. I'm ready for release on January 2nd. So yeah, we're going to have to wait about a day or so, to get those first ones in. They might have a surprise though. Who knows, right? I mean, they always seem to say it's like, well, we're going to have to wait 4 or 5 days, or, and then 1 or 2 hours after the encounter, it's like, hey, we've got all our pictures. So we'll see. We'll see.
Yeah.
Matt.
So yes, and like by when by we do our the ADL on the 2nd or on the 3rd, we might have some data, right?
We very well might, for sure. What's up, Tim?
I would like to ask you a question.
Sure.
Which body in the universe are you most interested in, and that you most focus on, and that you watch the most?
Oh, yeah. I really don't have any kind of a focus or anything. Yeah, that's a hard one because I really like it all.
I really love the poster.
Yeah, isn't this a cool?
Well, perhaps maybe the one that you get to see the most of.
Yeah, I'm not really focusing on particular things at this point. Probably, I mean, what I can basically do is photometric measurements, right? Which is just measuring the brightness of things. So variable stars, all kinds of variable stars, transient events. So bright supernovae. I'm trying to think of other things. Comets, right? Definitely be able to measure light curves of comets. Moons of planets, they vary in brightness as they go around the planets, because we're seeing different faces, different portions of the moons as they go around the planets. So yeah, those kinds of things. But specifically right now, I don't really have anything.
You actually just reminded me of a story that the rings of Saturn are getting thinner and thinner and thinner, and they're going to disappear.
Yeah, I've had to change my calendar. I've had to change my plans because in like 100 or 200 million years, they're going to be gone.
Mm-hmm.
So that completely just revises all of my plans. I'm going to have to do something about that. So yeah, and I'm not surprised, right? That kind of thing goes on. And really, you know, when I hear those kinds of things, I sort of take those with a grain of salt, because we haven't really had enough time to make, you know, lots of observations, right? We've been looking at Saturn's rings in detail for, you know, maybe 100 years, right? Maybe, right?
I think it's going to be a bit more than that.
Yeah, and so, you know, I don't think that we have enough data to really be sure about what's going on at all, right? Like I always say, you know, we take our data and we put it into these models, right? And these models say that Saturn's rings are going to be gone, right? But based on, you know, the data that we have, which just isn't enough. It's not enough yet. So, you know, take those kinds of things sort of with a grain of salt. You know, keep the skepticism high.
I just can't see those things happening in a few hundred years. I really can't.
Yeah, no, I mean, we've been observing Saturn's rings, you know, for just 100 years or so, right? So what I'm saying is that is definitely not enough time to really have a good idea as to what's going on there. So, you know, to come to a conclusion that, you know, they're going to be gone.
Is there any time reference for how long those rings have been there?
My guess is that there are theories about that, but off the top of my head, I don't remember what those numbers are. You know, I wouldn't be surprised.
I'll bet bigger than our lifetime.
Definitely. Oh yeah. You know, I mean, for sure, these kinds of things, you know, evolve over the course, you know, of millions of years, probably.
I would imagine.
But yeah. But I mean, really, we don't really know enough, you know, to even come to that kind of conclusion. You know, maybe there are things going on, you know, that we're just, you know, not aware of yet, right? But, you know, we plug all this stuff into our models, and the models say this. And, you know, can we trust the models? Yeah, maybe. I don't know.
I'm sorry if I'm asking too many questions and being a pain in the ass.
Ask away. Yeah, you know, that's what this is all about. You know, this live stream is for everybody. So questions, but, you know, I can guarantee that a lot of the answers I'm going to give you is going to be I don't know. So and, you know, that's why science is so great, because
I think that's the most honest answer. I don't know.
I don't know. And you know, even if we say that we do know, I always like to sort of say, you know, how confident are we? You know, okay, you know, are we absolutely certain, you know, that things happen like this? And it's like, well, you know, I'm 90% sure, you know, or 10% sure. So, you know, yeah. But
I don't think we can be absolute certain, because there are things out there that we don't understand. There's a lot of things that affect what we call our science. We know what our science is, but there are a lot of factors that we can't even comprehend.
Yeah, we just haven't, you know, been around long enough to you know, collect the data that we need, you know, to come to any kind of, you know, firm conclusions about anything. So that's why I say, keep the skepticism high, but keep an open mind though too, right? I don't like to shut anything out at all, because all the things that we think we know now, right, were once literally crazy ideas, right? Absolutely crazy. The Earth goes around the sun. You've got to be kidding. Isn't it obvious that the sun
Yes, I
goes,
know.
goes around the Earth? Isn't it obvious? Right? And here's all of our models, right? We take our data, we put them into our models, and the models say that the sun goes around the Earth. It's obvious. It's a done deal, right? Well, that's probably wrong, and there's this crazy idea, in somebody's head that it's like maybe the Earth goes around the sun, right? Or maybe we can build a machine that can fly in the air. Maybe, right? Maybe we can build a machine that'll go past the speed of sound, which was impossible, right? Which is absolutely impossible, right? Crazy idea, right? So I don't like to throw out any of the crazy ideas, because a lot of those are going to become our truths.
Well,
And
the one that really boils my bubble is the flat Earth theory. It's not flat. It never has been and never bloody will be.
yeah, I think I haven't really studied that much, but what they're doing there is they're sort of going at this from a different angle. It's not a scientific approach. I forget what the terminology is, um, 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 but it's some kind of different method of trying to interpret the data, and the conclusion is a flat Earth. And I mean, honestly,
the Earth has never been flat. Never.
I don't think so. I don't think so. There's a lot of evidence, right, that says that it's a basically a sphere, right? And I think we're pretty confident with that. So
I mean,
so
the way I see it is you've got all these bodies out in space. Every single one of them is spherical or round or whatever you want to call it, but they're all the same kind of shape.
Yeah, and that is extremely convincing, right? It's like, you look around and it's like everything else is a sphere. Why wouldn't the Earth be a sphere? So yeah, that's a convincing statement, right?
And
So,
everybody should know that the Earth is round and stuff, so it can really help with propagation and stuff. Because if the Earth is flat, you may not get your people.
right. See, that's another piece of data, that sort of points to us to a spherical Earth. So confidence with the spherical Earth is very, very, very high, right? But yeah, I've still to I've yet to really look at the arguments for flat Earth, because when you say flat, that's kind of a weird term anyway, right? Because that sort of implies two-dimensional, which is another thing.
Indeed.
I don't. Yeah. So I mean, but is that just sort of a general term, or I don't know what any of that means. I mean, it's sort of like life, right? We want to look for life, right? Well, what is life? I don't know. How do you define that? So the same thing with the word flat. It's like, well, what do you mean
even life itself has been defined by the fact that the Earth is round, because you get the sun at certain times and you don't get it at other times, and it's the seasons. So you get I don't know.
Yeah. Just keep an open mind. Take a look at what they're saying, and that's something that I haven't done yet. I started to. I think it was actually Tom who mentioned sort of the scientific approach that they take, and I looked at it, and that's about as much as I did. I need to jump back onto that because it was kind of interesting. Definitely want to learn a little bit more about that kind of methodology. That can bring somebody to that kind of a conclusion. Because it doesn't really seem to jive with what we're experiencing. But again, it's like, well, sun going around the Earth seems to jive with what we're experiencing, right? So
makes sense.
Don't know. Keep an open mind. But yeah, I think the flat Earth thing, whatever that means, it doesn't seem to hold much water, and pun intended.
Definitely pun intended.
Yeah,
it doesn't hold much water.
Yeah, it doesn't seem to. But like I said, I haven't really investigated it, to my satisfaction, to go one way or another. So, to ridicule it and, to put it down before, you totally understand what they're trying to do and what kind of approach they're trying to make, that's not fair. That's not fair. You've got to give these things a shake, right? Just because
the one thing I've found with flat earthers is they're willing to rip you down and they don't care how they do it. But the people that are for the globe, they give them the chance to speak their mind, and they just tear us to pieces, and we give them their chance to speak.
Yeah, it does seem that
does that make sense?
Yep. From what I've seen, they do seem to be a little bit mean, a little bit sort of aggressive. But on the other side, people hear things like flat Earth, and right away, they're just like, that's BS, right? That's just that's hogwash, right? Yeah. Well,
just total complete boulder dash.
Yeah, but I don't agree with that. I don't like that approach either, right? I like to look at things, and try to understand where they're coming from, but they do seem, they seem to be a little bit harsh, a little aggressive, but yeah, I really haven't investigated all that much, to come to any kind of conclusion at all. Maybe they're wrong about some aspects, but maybe they're right about others.
If they're going to say they're wrong, they just don't want to be right.
Yeah. Good friend of mine once asked me, would you rather be happy or right?
I'd rather be happy.
I think I would too. It's kind of interesting.
I would agree as well.
Yeah.
Because if you always tell me I'm wrong, I don't want to be right. I just want to be happy.
Yeah.
It would be nice to be right and have it
and
all.
happy.
But at the end of the day, you can't have both, can you?
Well, you know,
And not
oftentimes
spit
you
on
actually,
somebody's faces, and not spit on anybody's faces.
yeah. Actually, I think that you can be both. So, you know, that's kind of, you know, that kind of question isn't, you know, quite fair. But yeah, given the
Good
choice,
point.
but you know, there are lots and lots and lots of people who would much rather be right, much rather, much rather.
Anyway,
So
Matt, before we go, can we get back to the point that you were doing your video for? I'm sorry, I took you away from what you were doing.
no, no, no. This is a open porch. We go wherever we want to go.
As long as you don't mind, my friend.
Not at all. So, you know, bring me back. Where are we going?
Rewind the tape.
Rewind the tape. So yeah. Well, you know, speaking of which, it looks like we are just a little bit past the hour. So you know, this live stream often goes, you know, well past an hour, but I like to keep it close to an hour if I can, just because that sort of seems to be a reasonable amount of time. I like to go too long here. So yeah. So all right, well, that is what is going on soon. In just a few days, New Horizons going to be going by Ultima Thule. Um, nobody has any idea, not a clue. You know, they have a basic um, um, guess in terms of the size. They've been looking at this thing closely, you know, to make sure that there isn't any debris, any rings, no little moons or anything. And I think they concluded a few days ago that doesn't look like there's anything there, you know, because they don't want to, you know, point this thing at some kind of, you know, ring system, some kind of debris or moons or anything, smash into them. So, you know, they took a good hard look. I don't think that they saw anything, so they are full speed ahead, and who knows? I mean, you know, it's going to look like a lot of the asteroids and comets that we've already seen, right? I mean, it's probably going to be rocky. Um, what kind of shape, though? You know, a lot of the details and everything. You know, who knows, right? You know, there might be buildings and houses and Christmas trees. Who knows, right?
Hey, there might even be intelligent beings. Who knows?
You never know. You know, they might shoot the thing down as it goes by. So who knows? You know, I mean, we have absolutely no clue at all, and
That's the truth.
that is the excitement of discovery, right? You're going to a brand new place. It's just like you know, Magellan going around the world, Columbus, you know, running into a landmass where
Yeah.
yeah, where you know you really weren't expecting one. And nobody knows what this thing is going to look like, what it's going to be like, and New Horizons is packed full of instrumentation. Right, they're going to be able to take spectra, they're going to be able to look at magnetic fields, they're going to be able to measure its mass, its size, its shape. Um, you know. See what it's made of, you know, and they are just flying by it, right? So they're not going to stop. You know, they can't, right? They're going way too fast. So, you know, they're going to zip by it really, really fast. But, you know, as they go by, it's like, you know.
Do you know what's weird?
Uh-huh.
It's weird that we used to travel across the seas, and we'd have Christopher Columbus and all them, and now we're traveling across the skies. It's the same thing, but way, way, way up there. It's so different nowadays.
Do you understand the concept of fractals?
Yes.
It's fractal.
Yeah.
We're doing exactly the same thing, just on a completely different scale. But it's exactly the same thing. Precisely the same thing. It's, a lot of risk, really expensive. The payoff is big. It's exactly the same thing. In fact, even the timelines are exactly the same, right? I mean, it takes I think it took Voyager like what, 2 or 3 years to get to Jupiter, and that used to be how long it took to go around the planet in one of these sailing ships. So the timelines are even exactly the same.
I know.
So
I know,
it's the same thing
but
over and
in
over and
real
over
terms,
again. Yeah.
Them 2 or 3 years are seconds in our lifetime. Really.
Yep. Exactly. So yeah, this is all just a repeat. It just, just a different scale, but it's, the exact same thing. Yep. All right, well, cool. I think I'm going to get out of here for now. So thanks, everybody, for coming in. Have a great evening, a great day. You can subscribe if you wish. Hit the bell when you do
Can I
that.
ask you a question, please, Matt?
Down. Yes, please.
Could you send me the link each night for these shows, please?
Yes. Well, like I've explained before, what you have now done is turn the switch on. So every single
It's
day.
the same link.
No. But each day, I'll send you a new link every single day, and I will continue to do that until you tell me to stop.
I will never tell you to stop, but I'm much appreciated. Thank you so much. Thank you.
Very, very, very cool. Yeah. I think this is really, really cool that, we can get together like this live. You're in the UK. I'm in the southwestern United States. We're far away, right? But
indeed, it's true.
but there you are, right there. So it's extremely cool, and like I said, I think that we haven't seen anything yet. So, all right. Well, I'm going to get. Yeah, absolutely. All right, you guys. So I'm going to get out of here. So take care, and I will see you in a little less than 23 hours from now. Just a little bit less than one quick spin.
On the flip side.
Tiny little planet. Yeah.
It's spinning around, spinning good.
Don't get dizzy.
Longer than the moon.
Oh man, it's just dizzying, to think about this. But but it's all right. Just hold on to your hats. We'll be good. All right, you guys.
All the best, Mark. Thank you.
Take care. We will see you later. Bye.